Hello, you're welcome to Nkumat Online Academy. Today we are going to continue with our discussion on trigonometry and we are going to discuss special angles. Special angles, they are commonly used angles in mathematics. And so we are going to learn how to drive to get the special angles. That is how to get them, how to drive for the special angles. That is what we are going to focus our attention on in today's lesson. The special angles we are going to learn how to get are angle 30 degrees, angle 60 degrees, and angle 45 degrees. These angles are commonly found or commonly used in mathematics, and so we have to learn how to get them, how to drive these special angles. Let's start with angle 30 and angle 60. For us to get these angles, we still use our trigonometric laws, that is using the SOHCAHTOA method. The first thing to do is to get the right angled triangle for the angles. If we have a triangle like this where all the sides are equal, that is where this side is equal to this side and this side is equal to this side, an angle where the three sides are equal, then the three angles are also equal. And you should remember that the total angles in a triangle is equal to 180. That means that if all the sides in this triangle are equal, then the total angles in this triangle is equal to 180, and the angles in each of these should be 180 divided by 3. 180 divided by 3, which will give us 60 degrees, which means that the angle here is 60 degrees, the angle here is 60 degrees, and the angle here is also 60 degrees. Now, assuming that the lengths are, let me say we have this length 2, 2, 2. So if the sides are equal, that means that if one of the sides is 2, then others will also be 2. So let's assume that the sides are 2, 2, 2 each. Now from this, we can have something like this. We can divide this angle into 2. If we divide this angle into 2 equal half, this one will become 30. From here, this one will be 30 and this side will be 30. And that means that this side here is now divided into 2. That is, this 2 for this line is now 2 divided by 2, which is now 1. That means that half of this side is 1 and half this side is now 1. So the angle we are now going to get from that is, we are now going to get something like this, where this place is 2, this place is 1. Now this place is 30. We are taking half of the angles. This place is 30, sorry. We have divided the 60 into 2, so we have 30 here. This one remains 60. And if we are dividing it into equal sides, that means that this one is going to be perpendicular. That means that we are going to create angle 90 degrees here. And if we create angle 90 degrees, then it will be easy for us to get this side using the SOHCAHTOA method. Okay, so how do we now get this side? We don't know this side. That is this one, that it is not 2. We have to find it out. That is this line. So how to get it is now, we can say, using Pythagoras theorem, With Pythagoras theory, this is the hypotenuse because it is facing the perpendicular side. Okay, so here is the hypotenuse. Now, these two sides are adjacent. This one is an adjacent, this one is an adjacent. That is adjacent and opposite, depending on the angle you are considering. So, we know that the hypotenuse squared is equal to the sum of the adjacent squared. Now, that means that 2 squared is equal to, this side is 1, is equal to 1 squared. Let's call this place x, plus 2 squared 2 squared 2 squared is equal to 1 squared plus x squared. 2 squared is 4 is equal to 1 squared is 1 plus x squared, and this means that x squared is equal to 4 minus 1, which is equal to 3, and that means that x is equal to root 3. Taking the root of x squared, it becomes x is equal to root 3. So that means that this side is now root 3. You have now gotten this side as a root 3. Alright, so with this, we can now find any of these angles. Let's start with 30. To get the special angle 30, let's draw the angle again here. We have, here is root 3, here is 2, and here is 1. Here is 30, and here is 60, while here is 90. Alright, even if you don't know that this place is 90, like here, after dividing it, you should ask yourself, if this one is 30 and this one is 60, the total angle in a triangle is 180. So that means 60 plus 30 is 90, then the one remaining is 90. So without even knowing that this line will divide it into a perpendicular line, when you calculate the angle, it will still give you 90 degrees. Okay, so this place is perpendicular, that is 90. Alright, so if we want to take angle 30 degrees, let's now look at the special angle sine 30. From this sine using SOHCAHTOA, the trigonometric ratios, using SOHCAHTOA. Alright, sine is opposite of a hypotenuse, which is equal to, we are considering this angle, that means that this side facing it is the opposite. So 1 is opposite, which is 1 over hypotenuse is 2. So sine 30 degrees is equal to 1 over 2. If you use your calculator and find sine 30 degrees, you are going to get 1 over 2 or 0.5. Even if you use your 4-figure table, you are still going to get this. So this is how to get sine 30 degrees. So if you are in a haste and you couldn't get, or you can't get your calculator while you are writing your exam and you want to confirm the angle 30 degrees, what you do is that you quickly draw this diagram and then solve for the sides, and then you can drive your sine 30 degrees by yourself. Now let's look at cos 30, considering the same angle. Cosine 30 is equal to, sine is equal to adjacent over hypotenuse. Adjacent here now is root 3 and hypotenuse is still 2. So we have is equal to root cos 30 is equal to root 3 over 2. And then if we consider tan 30, tangent 30 is equal to opposite over adjacent. Opposite is 1, adjacent is root 3. So we are now going to have that tan 30 is equal to 1 over root 3. So here we've seen how to get sin 30, cos 30, and tan 30 by drawing the triangle and then getting the sides of the triangle. If you use your 4-figure table or calculator to get these angles, what you are going to get is equivalent to these things we have here. Now let's look at the angle 60 degrees. For angle 60 degrees, sin 60, for sin 60, if we are considering angle 60, that means that this side becomes the opposite, while this side now is now the adjacent. So sin 60 is now going to be opposite over hypotenuse, which is equal to root 3 over 2. Root 3 over 2, sin 60 is equal to root 3 over 2, that is opposite over hypotenuse, while cos 60 is equal to adjacent over hypotenuse, which is adjacent is now 1 and hypotenuse remains 2, 1 over 2. So cos 60 is equal to 1 over 2. Now tan 60 is equal to opposite over adjacent. Opposite is root 3 over adjacent is 1. So root 3 over 1. Root 3 over 1 is tan 60 is equal to root 3 over 1. So this is also how to get the angles, that sin 60, cos 60, and tan 60. Now looking at this, we can see that cos 60 is equivalent to sin 60. Sin 60 is 1 over 2 and cos 60 is 1 over 2. If you use your calculator and get amperes for cos 60, you are still going to get the same thing that you have for sin 30. Also, sin 60 is root 3 over 2. Let's check cos 30, root 3 over 2. So two of them are equivalent. You should always remember this. Now let's look at angle 45 degrees. For angle 45 degrees, now let us assume that we have this, where all the sides are equilateral. So if all the sides are equal, here is 90 degrees, here is 90 degrees, and here is 90 degrees. If we divide one, or we create a dissection or a diagonal from one end to another end, that means we are dividing 90 degrees here to 2, so which we get 45 degrees. We have 45 and we have 45 here, 45. Now let us assume that the sides are 1, 1, 1, 1. Now that means that if we carve out half of it, we are now going to have something like this triangle. This is, and then this is 1, let me write it again. We have 1, 1. So what is this side? Using, this is 90 degrees, this is 45, and this is 45. Now using Pythagoras theorem again, this is the hypotenuse. H squared is equal to 1 squared plus the other adjacent is 1 squared. H squared is equal to 1 plus 1, and H is equal, this is equal to 2, so H is equal to root 2. So here H is equal to root 2. Root 2. Now let's look at sine 45, cos 45, and tan 45. Sine 45 is equal to opposites of a hypotenuse. Let's consider this one. The opposite is 1, hypotenuse is root 2. So we have sine 45 is equal to 1 over root 2. Cos 45 is equal to, cos is equal to adjacent of a hypotenuse. Adjacent of a hypotenuse, which is equal to 1 over root 2, is equal to 1 over root 2. Then tan 45, tan 45 is equal to, tan 45 is equal to opposite over adjacent, which is, opposite is 1 and adjacent is 1, that is 1 over 1. So we now have 1 over 1. This gives us 1. So we now know that sine 45 and cos 45, two of them are equal. Why tan 45 is equal to 1. In exams, they can combine these angles and ask you to find their ratio. They can say, find the value of cos 45 plus tan 45, or cos 30 plus sine 45. The only thing you do is that, knowing how to drive this in, knowing these special angles, you just write the ratios, that sine 30 is 1 over 2, then maybe tan 45 is 1, or cos 45, you write the ratio for it, add two of them, and you get your answer. Okay, let us create a table for this. So we have now discussed sine, cos, and tan. Sine 30, we have 60 and 45. Sine 30 is 1 over 2. Cos 30, should be root 3 over 2, while tan 30 is 1 over root 3. 60, sine 60 is root 3 over 2. Cos 60 is equivalent to sine 30, 1 over 2, and tan 60 is root 3 over 1. Yeah. Now 45. Sine 45 is 1 over root 2, and the same thing with cos cos 45, 1 over root 2, while this one is 1. So this is the table for the special angles. They can combine any of these angles and ask you to find the value. That is the essence of this class. In case they combine cos 30 and sin 60, you just find the ratios. They can say cos 60 minus tan 40 or divided by tan 40 or anything. It can be addition, can be subtraction, can be multiplication, it can be anything, any arithmetic they can do with it. So anytime you see this, you know how to go about with the question. So that is what we have in this class, and I believe that you can drive these special angles anytime you are asked to do that, and anytime you are given any combination to work on, you can do it using these special angles we've gotten. Thank you.